start as soon as I can start. Alright, so first up, let's move to the mapping diagram. So we got two examples here. The first example is what not to do. This is not a function. This is because each domain should only have like one corresponding element in the range part. Because if it have two, for example, like this top part here, right? If it has two, if it shares with two, if you were to graph it out, for example, if you were to graph it out, 1, 0, and -1, right? If you were to graph it out, you would get something like this, and this and as you can see, as those two have explained, those it would not pass the vertical line test. Therefore, this is not a function. But you see here, since it doesn't have like the same arrows like this, right? This is a function, since each one of the x here have its own separate no, not own separate, only has one corresponding element of the y. So yeah, moving on to equation. For equation, it's easy to determine if it's whether a function or not a function. It's really simple, because to determine what's a function, what's not a function, you gotta look at the y. As long as the y is not squared, then it's a function. Since this y is not squared, it's a function. Yeah, function. But then take this as an example. Since this y is squared with this y, this makes a circle on the graph. And if you, again, do the vertical line test, boom, it will be intercepted, and yeah, making this not a function.
Okay, is there another example that you can give for the y squared is not a function?
Y squared is not a function. Oh, I could. So for example, I have one more. If you were to do something like this, plus, let's say 5, right? Assuming that you make x into a 4, right? If you add it together, here like this, y would have two possible answers. It will be either a -3 or a 3, making this not a function. Because y, in any relationship, y should only have one function. No, excuse me, one variable, one answer in order to make it a function. Therefore, that's why y shouldn't be squared.